Welcome to Quantum Leaps, the podcast that explores the bleeding edge of technology, quantum entanglement, unlocking the future of secure global communication. Have you ever heard of something so strange that it sounds like science fiction? Imagine two tiny particles linked together in a mysterious way. No matter how far apart they are, whether they re in the same room or on opposite sides of the universe, what happens to one instantly affects the other. This isn't a sci-fi movie plot. This is quantum entanglement. Albert Einstein famously called it spooky action at a distance. He was skeptical, but his doubt actually sparked decades of research that proved this mind-bending phenomenon is very real. Today, scientists aren't just observing entanglement in labs, they're demonstrating it over thousands of kilometers, and with more particles than ever before. This spooky connection is about to revolutionize our world, starting with something we all care about: security. Let's talk about the internet. We use it for everything: banking, messaging, sharing our lives. But have you ever worried about how secure your data really is? Current encryption methods are strong, but they are not foolproof. A powerful enough computer, especially a future quantum computer, could potentially crack them using brute force, trying every possible key until it finds the right one. This is where quantum entanglement changes the game. Imagine sending a secret message, but instead of just encrypting it, the key to unlock it is shared between two entangled particles. Here is the brilliant part. If a hacker tries to intercept or even just look at one of these particles, the delicate quantum link between them shatters instantly. The very act of eavesdropping destroys the connection, immediately alerting the sender and receiver that someone is trying to listen in. It's like having a security system that's triggered by the intruder's shadow. This is the core idea behind quantum key distribution, or QKD. By using entangled photons to create and share cryptographic keys, we can build a communication channel that is, by the laws of physics, unhackable. Any attempt to break in is an attempt that fails by default. It's the ultimate digital deadbolt. So, is this all just theory? Absolutely not. This technology is leaving the lab and going global. China launched the MISHA satellite, the world's first quantum communication satellite, which has successfully distributed entangled photons between ground stations over 1,200 kilometers apart. It's a huge leap, proving that space-based quantum networks are possible. Back on Earth, scientists and engineers are building terrestrial quantum networks. They're reusing existing fiber optic cables and developing new free space laser links to connect cities and even continents. Imagine a network stretching from Beijing to Shanghai, or from Washington, D.C. to Boston, all secured by the fundamental principles of quantum mechanics. Who would use this? Think about the most sensitive data in the world. Financial institutions could conduct transactions with zero risk of interception. Governments could secure classified communications against foreign espionage. Critical infrastructure like power grids and water supplies could be protected from cyber attacks. It's about creating a layer of trust in our digital world that is physically guaranteed to be secure. The era of quantum communication isn't just coming. It's already being built, piece by piece, all around us. And quantum key distribution is just the beginning. The ultimate goal is something even more ambitious: the quantum internet. Picture a global network where quantum devices, or nodes, are all connected through entanglement. This wouldn't just be a faster or more secure version of our current internet, it would be a completely new paradigm. It would enable things like distributed quantum computing, where multiple quantum computers could work together on problems too complex for any single machine. It would also unlock the true potential of quantum teleportation. Now, hold on, we're not talking about beaming people from one place to another like in Star Trek. We're talking about teleporting information. By using entanglement, we could transfer the exact quantum state of a particle from one location to another without physically sending the particle itself. This would be a revolutionary way to move data within a quantum network. Of course, there are huge challenges to overcome. Quantum states are incredibly fragile. The slightest disturbance from the environment, a process called decoherence, can break the entanglement. Scaling up from a few particles to a global network is another massive hurdle. But with every new experiment, researchers are finding clever ways to protect quantum states, extend their range, and build more robust systems. The future is a connected web of entanglement, and we are just starting to map it out. So, what does all of this mean for you, for me, for all of us? On a personal level, it means a future where your digital life is truly private. Imagine your online banking, your private messages, and your entire digital identity being protected by an unbreachable quantum shield. Identity theft could become a thing of the past. On a societal scale, the implications are even bigger. It could fundamentally change national security, making cyber warfare as we know it obsolete and preventing catastrophic attacks on our infrastructure. It could foster a new era of global trust, where nations and corporations can interact digitally with complete confidence. The journey to a quantum-secure world is just beginning, and it's one of the most exciting technological races of our time. It's not just about faster gadgets or cooler apps. It's about rebuilding the foundations of our digital world on the unshakable laws of physics. The spooky action that once baffled Einstein is now set to secure our future. Keep an eye on this space, because the quantum revolution is happening now, and it's going to change everything. Thanks for watching, and if you want to stay updated on the future of technology, be sure to subscribe.